Welcome all for the series of sessions on operating system as a part of high performance computing course. In this session, we will try to understand some of the basic things about operating system, where we will try to understand what is operating system, need of operating system, followed by the basic components, types of operating system, and finally we will try to touch upon Linux operating system. So, let us try to understand what is operating system. Basically, operating system is a software that manages other resources on the system like hardware or the software. That it is the most important component that runs on your system, which manages all other programs on the system. It is the first thing which is loaded on your system when you start your computer. Without operating system, a computer cannot function efficiently, because operating system is the program which manages all resources like hardware or software efficiently. So, what is need of operating system? Operating system is the component, as I had mentioned, which manages other resources. So, computers would be difficult to use, highly unstable and insecure and inefficient without operating system. Basically, operating system simplifies the user interaction, management of the resources, and ensures that the system operates smoothly and securely. So, let us try to understand some of the issues if the operating system is not present on that particular system. So, managing the complex hardware available on the system will be very difficult if there is no operating system, because any computing system possesses different kinds of hardware resources. So, if there is no operating system, managing those resources will be very difficult. Operating system inherently takes care of the security aspects. So, if there is no operating system, so that system will be very vulnerable for the risks. On any computing system, there are multiple tasks which runs concurrently. So, managing all those multiple tasks will be very difficult if there is no operating system. Again, the managing the memory aspects of that system would be difficult in the absence of operating system, like storing and retrieving data on the memory on the memory component will be very difficult, as the file system is the inherent part of any operating system. Then operating system generally provides a proper way of interacting with the users. So, if there is no operating system, then there will be limited user interaction for that particular computing system. So, managing the multiple peripheral devices will be challenging in the absence of operating system. In many cases, operating systems by default handles many errors on that particular computing platform. It gives some warnings if the system starts malfunctioning. So, managing those errors or handling those errors manually in the absence of operating system will be very difficult. Another aspect which operating systems takes care is networking. So, if there is no operating system available on that device, so handling the multiple devices in that particular network will be very difficult. So, all these are aspects which inherently operating system takes care. So, thanks to the operating system which has made the life easy of all the scientists, engineers or the users who uses that particular system. Let us try to understand some of the basic components of operating system. Very first and the most crucial component of operating system is the kernel. I can say the kernel is the heart of operating system, which acts as the bridge between the hardware and software available on that system. These are the different functions which kernel plays in the operating system, like process management, memory management, device management, and it also manages the system calls. Another crucial component of operating system is the process management. Actually, it coordinates the different tasks which are running on the system. It handles the creation, scheduling, and termination of the different tasks or processes on the system. It possesses different functionalities like handling the multitasking, CPU scheduling, process synchronization, inter-process communication, and so on. Another important component is the memory management unit, which makes sure that your program uses the memory resources efficiently. It is responsible for managing the system's physical and virtual memory, ensuring that each process has sufficient memory to run. Talking about the different functions of this unit like memory allocation, deallocation, memory segmentation, paging, and so on, like memory protection is also one of the crucial function of the memory management unit. File system management is another important component which deals the storing and retrieving of the data. This component manages how the data is stored, retrieved, and organized on the storage devices like memory units. It has the functions of file creation, deletion, access control, file storage, file organization, and so on. Device management is also one of the crucial part of any operating system, which takes care of management of the different peripheral devices like printers, disks, network devices on the system. It includes the functions such as device drivers, I/O management, buffering and spooling, and so on. User interface is one of the crucial features of any operating system. It provides different kinds of user interfaces like graphical user interface as well as the command line interface. Graphical user interface offers a visual interface for that particular system. CLI, that's the command line interface, allows users to interact with the system through the text commands, through the shell. Security and access control is also one of the important components of any system which ensures that system is protected from unauthorized access, viruses, and other threats. Authentication, authorization, encryption, these are some of the crucial functionalities of this particular component. Networking manages the network protocols, allowing the system to communicate with other systems over the network. It has the different functionalities like a data transmission, network security, resource sharing. So all these are the basic components of any operating system. So now let's try to understand types of different operating system on the basis of their functions. So generally there are 4 types of operating system based on their functions, that is their type of computers they control and the sort of applications they support. So the very first type of operating system is the single user, single task. In these systems, these are basically designed to allow only one user to perform one task at the same time. So the first generation mobile phones were operated with this kind of operating system. For these systems, the focus is on executing one job efficiently without the overhead of managing the multiple tasks. Another type of operating system is the real-time operating system, which handles applications that requires precise timing and immediate processing of tasks. So, the systems in the industrial machineries possess such kinds of operating system. Another use case is the medical equipments, which requires timing and reliability are the critical aspects of those systems. So, where the RTOS kind of systems are used. Then another type of operating system is the single user multitasking, where there is a one single user at a time operating that system, and that particular user can run multiple tasks at the same time. So, Windows operating system is the good example of such kinds of operating system, where one user can log in and he can perform multiple tasks at the same time, like browsing, playing the music and so on. So, such kinds of systems are common in personal computers, laptops and smartphones. So, the Mac OS and the Androids are another examples of single user multitasking type of operating system. Another type of operating system is the multi-user multitasking. In these systems, multiple users can run their jobs at the same time and every user can run multiple jobs. So, multiple users and multiple jobs can perform on that particular system through this kind of operating system. So, Linux is one of the great example of such systems. So, as I had mentioned, multiple users can log in to these systems at the same time and can work locally or remotely. They can access this system from the remotely as well and they can run multiple jobs. In the server segments, this operating system is widely used. On the systems like HPC, like high performance computing system, there are multiple users who can access this system at the same time and every user may have multiple tasks to perform. So, on such systems, the Linux is the primary component which powers such kinds of systems. So, let us talk about brief aspects of Linux operating system. So, Linux is basically a popular open source operating system which is known for its versatility, security and stability. Linux has its roots in the Unix operating system, which was developed in 1969 at Bell Labs by Ken Thompson and Dennis Ritchie, followed by Andrew S. Tannenbaum developed a Minix operating system, and Linux is basically the next version of the Minix operating system. Linux was developed by Linus Torvald and he started developing a new free operating system kernel in 1991. He released the first version of the Linux kernel in September 1991 under the free software license, and at the same time there was another project led by Richard Stallman, that project named as GNU project, under which he was developing different tools like compilers, libraries, and this Linus Torvald joined hands with GNU project to create full-fledged and free operating system. So, when we talk about the key milestones in the journey of Linux operating system starting from 1991 to 2020, so in 1991 Linus Torvald releases the first version of the Linux kernel, followed by in 1992 he adopts the GNU general public license. Then in 1993 the first major Linux distributions like Slackware and Debian were released. And in 1994 the Linux kernel version 1.0 was officially released. Another important milestone was like release of the Ubuntu flavor of the Linux, which then become very popular in the segment of desktop community, and in 2008 in the smartphone segments Android was released, and Android is basically powered by Linux kernel. And in 2020 basically Linux has become the most popular operating system in the user community. So the role of Linux in HPC system is very crucial, as on the HPC system there are multiple users who works on this system at the same time, and every users run the multiple jobs. So in that sense, to run the show of high performance computing system, Linux is the crucial component. In a one sense, we can talk as Linux is the heart of HPC system. So let's talk about some of the basic characteristics of Linux operating system. As I had mentioned, it is open source and has the strong community support. It is based on the kernel. It supports the multi-user multitasking. It is highly secure because of it regular updates comes. It has the different variety of flavors starting from the mobile segments to the server segments. It is customizable, so the different users can customize it according to their uses. Is known for its high performance and stability. It supports the different flavors, supports the different package management components like apt, yum, DNF and so on. Let's try to understand the Linux OS structure, where exactly the operating system fits and what are the main components of this system. Whenever you run any program, in which layer that program goes to the hardware. Let's try to understand that aspect. As I had mentioned, Linux is the most popular open source operating system. So consider that there is an user, right, and he has some program to run on hardware system, right. So generally user sends this particular program to the computers or the computing unit, then this particular machine does some processing on that particular program and give back result to user. So inherently how this particular system execute that particular task, how it interacts with the hardware resources, in through which pipeline it goes, let's try to understand that aspect. So there is a user which he has some application to run upon. So this application first goes to operating system, then operating system becomes the bridge between that application and the hardware, and then hardware performs some operations onto it, and then again through the operating system the user gets response with respect to that program. So operating systems lies between the user's applications and the hardware. So it simplifies the life of the user who is using that particular system. It hides the complexity of the hardware to get the results in a efficient and in a proper manner. So in the operating system as well, in which flow that particular program goes. So that particular application or program first goes to cell, and cell is nothing but an interface to the kernel which hides again the complexity of the kernel functions from the user. There is another aspect which is crucial in this journey, where the system libraries, which is a bridge connecting the applications and the kernel, offering a standardized and efficient method for application to engage with the underlying system. And then finally there is a kernel who is basically directly interacting with the hardware, and whatever the results get from the hardware, this component gives back those results to the user. So in this scenario, whenever any user runs application, in this particular flow, that application gets executed on the system and accordingly he gets the result. So, this is a just recap of this session. So, what we have understood as of now, we try to understand the what is the operating system, need of operating system, followed by the basic components of it, types of operating system, and then briefly touch upon the Linux operating system. So, in the next session, we will try to understand and learn in detail about the Linux operating system and its components in detail. Thank you.